Good evening. Before we begin, we would like to acknowledge that the land on which each of us is sitting carries the heritage and culture of the indigenous people, First Nations of North America. We honor the indigenous people's connection to these territories, and we respect the land on which we gather today. My name is Denise Leader-Stober, and I am the Programming Development Specialist for Cal Poly Arts, which is a department of Cal Poly University in San Luis Obispo, California. It is in connection with my work there that I first met David Gonzalez, and he has introduced me to this project. And it is very exciting for me to be affiliated with it tonight and to be here with you. I would like to remind you to use headphones for the best experience, and also to leave questions and comments on the YouTube live page comments section. The goal of the Effects of Gravity project is to produce and eventually tour a live multimedia stage production exploring through equal parts music, poetry, and astrophysics our cosmic origins, with the hope that a broader perspective helps us become better stewards of the Earth. The project gathers the collective voices of spoken word artist David Gonzalez, composer-guitarist Alvaro Domene, and astrophysicist Dr. Luke Keller. To achieve the goal of creating a new live show during COVID-19 pandemic, the Effects of Gravity team has designed a year-long virtual rehearsal, a production and live stream project. Tonight we will see episode 4, Planet and Star Formation. You can see the previous episodes on the Effects of Gravity YouTube channel. Now, join me in watching episode 4, Star and Planet Formation.
A cloud of gas collapses to form a cluster of stars. The cloud is only 16 trillion miles across and is located within our own Milky Way galaxy. It has the mass of 500 suns. The collapse forms regions of higher density and temperature, indicated by orange and yellow. These collapse further to form stars, the growing swarm of small white dots. The star formation process, presented here in just over a minute, typically takes from hundreds of thousands to millions of years. It all started with a vanishingly tiny effect of gravity, the attraction between individual hydrogen molecules in the cloud. Leave them alone for enough time, and you get stars. We revisit the simulation of forming stars, but now each box follows the evolution of an individual new star, beginning at the moment of its formation. Each box is a tiny region, its size measured not in trillions of miles, but in billions of miles. The effects of gravity don't stop with the formation of stars. Each one clings to a bit of its natal cloud. Planets assemble from these gassy, dusty disks and spirals. In the end, planets are invisible next to the intense light of a luminous point, the star they orbit. view is now just 100 times the diameter of our solar system. Planets form in gravitational instabilities. Wisps of gas that are slightly more dense than their surroundings collapse into dense masses called protoplanets. Some protoplanets survive to become planets, similar to our Jupiter. Some disperse. Planets are effects of gravity.
Emma, 3 years old, dips her finger into a puddle at the river's edge. She swizzles it around and around, delighting in the eddies and bubbles and the whirlpools she has conjured. I watch the draining tub, how the flatness of my bathwater spins into a vortex, how the emptiness consumes all. I confess a guilty fascination when I click into weather.com and witness chaotic, elegant imprint of our planetary origins in the fury of tornadoes that rip through the heartland and the hurricanes that beat Puerto Rico to a pulp. Dust and gas, plus the instabilities of the gravitational field, plus core accretion equal planets. Dust and gas, plus the instabilities of life, and the imperative to stick together equals the human condition. This swirling gravitational pull, this drawing in towards solidity is how the making happens. Stirring her conjuring pot at the fire, the shaman makes potions that create other worlds. All that is real, all that is imagined, all of us, all of it, born from one kind of gravity or another.
Hello again. It's now my pleasure to introduce to you the three gentlemen who have contributed to this project. First, I'd like to introduce Dr. Luke Keller, who is a professor of physics and astronomy at Ithaca College in Ithaca, New York. His astrophysics research focuses on the formation of stars and their planetary systems. So I wonder, Luke, if you could just give us a little bit of introduction of how you came to be associated with this project. Was it your idea?
Thanks, Denise. It wasn't my idea exactly. David and I have been working together for years, and we've always known that some combination of poetry and science would be a wonderful way to communicate an appreciation for both to the general public, especially students. And we've been mulling around, and then David introduced me to Alvaro, and we realized that music was what was missing. So my role has been to interpret the science and to help with tying the actual scientific models that we use. And these are not movies or special effects. They're computer models that are designed to simulate as closely and accurately as possible what's actually happening in the universe. in this case, what's happening in star-forming clouds and planetary systems. So that's my role as an interpreter.
Wonderful. How long have you been working on this particular project?
Just over a year now, we've been working on it.
And I assume you had to pivot rather quickly when you saw that you were going to be locked down.
We did. In fact, in February of this year, we were in the process of trying to line up actual live performances of the effects of gravity, which we had started, and then of course things changed for all of us, and we were kind of adrift for a bit, and then we had the idea, I think over cocktails, as many good ideas happen, that maybe we should turn it into a extended rehearsal online and have an audience who could both ask questions, but also help us to enhance what we're doing and help us bring it to the stage eventually.
Wonderful. Well, I'm going to let you go and say hello to David.
Hey, Denise.
Hello, David. I'd like to introduce you to our audience. You are a nationally touring poet, musician, and storyteller, a fellow of the Joseph Campbell Foundation, and you've received numerous commissions and awards. I understand your doctoral dissertation studied the intersection of improvised music and mythology in psychotherapy.
It's a mouthful.
Is that what you were doing when you came and worked with children here in San Luis Obispo?
Oh gosh, life is long, you know. My original work was as an arts therapist, as a music therapist, and I did a lot of different kinds of work. My doctoral dissertation was me trying to make sense of my own journey, because it was through Joseph Campbell's work and a deep study of mythology that I kind of got saved. You know, what do you call it? A born-again mythologist? I don't know. I found that story and poetry were things you don't have to believe in. You have to commit yourself to explore and have a personal understanding and engagement with the material. So that's been really fruitful for me in my own life. And so when I come to theaters like yours, I tell stories and do creative writing. And for me, that has been, not only my work, but my passion.
And this project would seem to really marry both of those interests together, the science and the the sort of mythological grandeur that science has given our culture.
That is a really nice way to put it. Campbell actually said that when myths are stagnant, they ossify, they become hardened, and then they fall apart. And cultures organize around myths. And he said that myths, to stay relevant, must continue to integrate the knowledge of the time. So we have in our knowledge base now the kind of simulations, understandings of cosmological phenomenon. We're not in Kansas anymore, and we're not in the solar system anymore. We're not the center of the universe. We are observing deep into the cosmos, and our myths have to reflect that. And we project our unconscious mind into our experience to make sense, to give language to it. And that's how I see kind of my role in this, is to put words from this little human body, this little human mind, onto this vast, unfathomable, actually kind of unimaginable, it's an interesting word to use, unimaginable space and reality that we are part of. This is a project which is really near and dear for me.
Well, now I would like to introduce Alvaro Domine. Alvaro is a Madrid-born, New York-based guitarist and composer operating at the convergence of various styles of contemporary creative music. His sound and compositions are influenced by the jazz and Western contemporary classical traditions, as well as metal music. He has released 14 records as a leader and co-leader, and is an active performer in New York's fertile music scene, leading various groups in addition to working with numerous artists. He's performed and taught internationally, and recently worked with Joe McPhee, Carl Berger, Elliot Sharp, Vinnie Golia, Henry Kaiser, Michael Bissio, Ben Goldberg, and Weasel Walter, to name a few. In addition, Alvaro co-runs Illuso Records. This is an independent record label dedicated to support and disseminate creative new music. And he's also the artistic director at the Singularity Music Series in Kingston, New York. Welcome, Alvaro.
Thank you. Hi, Denise. How's it going?
Very well, thank you. It's a pleasure to meet you.
Likewise.
And it's interesting because David said he was trying to give language to this sense of greatness of space. And here you are creating the sound of the greatness of space. Can you talk a little bit about your contribution to this project?
Sure, yeah. Well, I see my role as not only contributing to what I believe is a standalone character to these stories, in this case, music, but also carrying the responsibility of the emotional impact of sound in the overall production. Music fleshes out and enhances the emotional landscape of an audiovisual production. It helps place the viewer within the temporal reality on the screen or on stage. So I take very seriously the ways in which I approach that task. And I'm very grateful, thankfully my partners in this project totally trust me with the freedom to fully express my artistic vision, which allows me the confidence to follow my intuition fully, without fear of rejection or judgment. And I work really hard at helping to create a convincing atmosphere of time and place with this music that I write for this project. And talking about my role, I see it as split in four. There are four main subcategories to what I think I'm doing here. One of them would be underlining the psychological nuances that are present in the pieces, because what I'm trying to do is to enhance or highlight the emotional content of both the simulations and the difficult scientific concepts that we're talking about, right? So that's one. I also serve as a kind of a neutral background filler when needed. Also building a sense of urgency to facilitate the dramatic buildup of a scene is very important, and to end bringing a piece to a close with the punctuation of finality. These are things that I learned from composer Aaron Copland, who published an essay called Film Music in 1940, in which he explained all these factors of how music impacts video or theater production, right? So in a wider general sense, sound design and musical ingredients not only help set the tone for the project's personality, but also create bonds with the audiences that witness it.
Well, hopefully our audience will have some questions or some comments about how they were affected by the sound, the poem, the visual, and the explanation for how stars and planets are actually born.
Yeah, don't be shy.
Yes,
Ask
exactly.
away.
Exactly. That's a little prompt to the audience. So I'd like to bring everybody in now and see if whether you would like to speak together about this episode and how it relates to the greater project, and how you would see this as a performance. Because I'm interested in that. Excuse me, but as a presenter of productions for youth, I have a program called Polyarts for Youth, and we take artists into the schools, and we also do assemblies and that sort of thing. How would you see this as a live presentation for audiences of all ages?
Well, spectacularly. I think there's a model for this. National Geographic, Nat Geo Live, I think is what it's called, right?
Absolutely, yes.
So spectacular images with a compelling, really well-crafted narrative that blends information, science, and, for lack of a better word, entertainment and/or poetics. I think that where we might distinguish ourselves a little bit from that is that we are really tunneling in onto a very specific subject in astrophysics with a professor of the topic and with a musician who is at the highest level of compositional and technical virtuosity, who's playing live. So this is if you could see Alvaro playing live, you just because it's spectacular. Nothing I've ever seen like this, and whatever. Then there's me, like the poet guy, you know. But I think we would have beautiful lighting, big beautiful screen, great sound, Luke illuminating these amazing phenomenon, and then having Alvaro play live and just kind of moving through. Our goal here is to actually tell a big story. Episode 1 was the biggest part of our what do we call that, Luke? The first episodes were on the biggest formations that we know, the beginning of it all.
Right, the formation of structure in the universe.
The formation of structure. Wow. And we're going to end up, if I'm not giving it all away. I mean, right now we're in planets and stars and planets, but we're moving in a way toward smaller and smaller structures, and we'll land here on this miraculous blue globe that has given us life and the consciousness to talk about it. So anyway, that's kind of a long-winded answer, but I think that our hope is that with the intersection of the arts and the sciences in a really highly produced sound, light environment, a video projection environment with our wonderful stage manager, that we would present a pretty glorious experience that would bring a lot of information, but also a lot of wonder and awe and curiosity and joy. That's a lot to say. God. Anyway, I put up before. I'm in charge of putting up the questions from the feed. Here's one that came in. Where'd it go? Here. Where'd it go? Here we go. Good question. Luke, I don't know. Denise, maybe you could read those out for us. I put them up.
Yes. The question is, we see spirals everywhere in nature. Is this some primordial imprint from space? I suppose this is in relation to the visual that you had of the spinning, and then also David's poem.
Yes. So we definitely see spirals in all sizes in all of nature. I would draw a distinction, though. So the short answer is that they are indeed everywhere. I wouldn't call it an imprint so much as it's actually a very stable structure. So there are spirals that occur because of the interaction of matter, and those are the spirals we saw in this episode. That we have bits of gas and matter encountering one another, and the force of gravity is causing them to be attracted to one another, but they're also moving, and so they sort of go into this spiral. That's also what makes a vortex going down the drain when you drain your bath, as David so eloquently said in his poem. There are other spirals like seashells, for example, which are structures that are built, and so that would be a completely different physical process. So in that sense, I wouldn't say that it's an imprint of the universe or from space, but it is a very common structure, in part because it's a structure that has sort of physical integrity.
And is that integrity a result of gravity?
It is in space. It is with these large structures where the spiral is literally it happens because of gravity.
I see. I actually had a question. The sun is a hot star, is that right?
It is our star, yeah.
How does it produce energy?
All stars produce energy by nuclear fusion. So they are in their cores hot enough. So normally in a gas that's warm, the molecules or atoms would be bumping into one another very quickly, but they bounce off of one another. If you get the gas hot enough, they stick together and they form heavier and heavier elements. And this is what's happening in the core of every star. It's what distinguishes stars from all other objects in the universe, that their luminosity, their brightness, is sustained by a source of energy from their core, which is literally creating atoms, creating the chemical elements of the chemical periodic table.
Huh.
I remember once we were on a walk, and Luke said, "Do you have anything gold on you?" And I think I had some gold on me at some point. He said, "Do you know where that comes from?" He said, "That's proof." No, I think that's what it was. What you're wearing there is proof that the sun that we are so attached to and born from it is a second generation. That is, the gold that's in the jewelry that you wear, that you cherish, comes out of the earth, which came out of the sun in the second generation, because the star had to collapse the first generation in order to get that intense of a reaction. Luke, I'm saying this badly. Help me. I'm drowning. But creating the elements of the periodic table in this furnace of star, in the depths of the star.
Yeah, that's right. So in the cloud that we saw collapsing at the beginning of this episode, everything that is in the planets which eventually form, orbiting those stars, all of the material was there in the beginning. So if there's gold on Earth, there was gold in the cloud that formed the sun. And if there was gold in the cloud that formed the sun, some other star had to form that gold and then redistributed it when it died back into the we call it interstellar space or interstellar medium.
We have a question.
Yes, we have a question from Dr. Marsupial. He wants to know, Alvaro, what is your vision? Oh, a different question. What is your vision for how your music will be experienced in a live performance of the effects of gravity?
Oh, wow. That's a good question. Well, music can work in very powerful ways to evoke memories and ideas. And by doing that, engage our thoughts and feelings. I think we can all agree on that, right? So I think music can quite simply contribute towards shaping the stories of our lives. At least that's how I have experienced music all my life, right? So I would be completely delighted and fulfilled if I could contribute to that in other people's lives. That's, yeah.
So you see this as an extension of the rest of your musical work?
Absolutely. Yeah. Absolutely. Because, sorry to interrupt, what I mentioned earlier, that these guys allow me, they trust me, so I feel like I have complete freedom in just following my intuition, and I'm doing what I do. This is not a session gig. This is what I do. So this is a field that I usually don't get to explore this deeply in other projects. But I get to do it here, and I love it.
David, that's a beautiful observation.
Yeah, this is one of my. So Carl Sagan is one of my heroes. Carl Sagan and Fred Rogers are my two heroes. They're the reason I'm doing what I'm doing. And this quote is, he was so eloquent. This is from the Cosmos series.
There's a question for you, David, again from Dr. Marsupial. He said, could you speak more to how you relate these phenomena of the universe to human experience?
Well, I have a question for Dr. Marsupial. What's up with your name, Dr. Marsupial? I love that.
He's just got a big pocket.
You've got deep pockets, Dr. Marsupial. No, Dr. Marsupial has been in a bunch of our live streams. So thank you for being part of our community and for asking your great questions. Let's see. You know, the unconscious mind is a terrible thing to waste. You know, I kind of believe in. It's not I believe. I trust first ideas. That when I watched these simulations, when I hear Luke speak, when I hear Alvaro's music, there's a surging, a surging from the unconscious. And in that surging, there's an accumulation of bits of imagery. The girl spinning her finger, seeing the bathwater. I can't tell you where that comes from. It isn't like I'm looking for it. I sit there with it, and I look at this imagery, and boom, it arises. And I don't want the answer. I don't even want to know the where and the why. I just love that it is true, that the unconscious mind is gathering, connecting. My job, as in this project in particular, is to synthesize these impressions from my own unconscious mind and to create sort of mini narratives that make the bridge from the lived human experience to this vast, truly awe-filled truth of our cosmic home. And to make these, it's untenable, right? I mean, you look up at the stars and, oh, it's nice, but when you really think about it, you're like, damn, I don't get it. Like, ouch, like, how do I fit? But there's also the other side of that. That is when our human experience, for example, our political experience, when it's sometimes we need to recontextualize to continue our sanity and to open the screen up a little bit, to remember the ongoing story, the deeper story, the older history, the deeper history, the context within which these aberrations occur. And then I think for me, at least, it gives me some solace to go on in the struggle, because I think we all have to face the fact that we are kind of mysteries unto ourselves, and we know what's what down the block, you know, what's happening. So for me as a poet in this project, it's to make that bridge between the unknowable and the known through the space of the imagination. I'm terribly long-winded here today, but there it is.
Well, let's bring this full circle. So now Dr. Marsupial would like to ask Luke, has working with a poet and a musician changed or evolved your perspective on these phenomena and your work as an astrophysicist?
I can be much shorter than David. Yes. Yes, it has.
Could you expand?
Yes. So, so the way that we're producing these videos is reminiscent of, but not exactly the way we would either start it or I think would perform it live, because we do it in pieces and then we put it all back together again. So, for example, I get the video. I get those from astrophysicists who are doing work, in this case, in star formation and planet formation, and do my interpretation. We know now that David has poems for each of these, and so we know what the poem is. And then we send it. I piece them together. I'm a very, very amateur video editor, and then send it to Alvaro. We know kind of where he's going with the music. We know the themes, I would say, from the various work that we've already done, but we don't know what it's going to sound like until it comes back. Mm-hmm. And I mean, Alvaro can comment, but sometimes I think maybe he doesn't know what it's going to sound because he needs to experience kind of the full picture and the ideas. And that's so right. that's a lot like science. It's a lot like producing science because people do it, right? And it's a creative process. All too often, I think we forget that the scientific process is a very creative process in the sense that you really, in a lot of ways, you kind of have to do what I just described, which is do the best you can to put things together, to put a story together. How does the universe work in this case? But then you got to sit back and observe and see what happens. So it really makes me appreciate that process a lot more.
Oh, Luke, you've disappeared.
You broke up for a second, Luke.
We lost you right at the end there.
Oh, I just my final comment was that this creative process really helps me with the scientific process when I do my work and when I do my teaching, which is a large part of what I do.
Well, it doesn't look like we have any more questions from the audience, but I have one more question. The sun is a hot star, and we think of the moon as being cold. There's as sort of opposites. So if the moon is cold, why is it cold? And if it isn't, why do we think it is?
So compared to the Earth, compared to the surface of the Earth, the surface of the moon is cold unless it is illuminated by the sun, in which case it's very warm. Because there's no atmosphere to mediate.
How cold, when you say cold, how is that?
How cold?
Yeah.
Like very minus Fahrenheit, hundreds. So, but the moon doesn't have a source of luminosity like the sun does. So the sun is much, much hotter because it's a star. The moon, we see the moon by reflected light. And so it is definitely cooler basically for that reason.
Thank you. David, do you have any questions that were left over from previous episodes?
Actually, there's a whole ton of them, but I kind of think that we kind of nailed this one today.
Well then, if that is so, I would like to thank everybody for joining us this evening, and I would like to thank you, gentlemen. It's been an absolute pleasure to meet you and work with you. And I'd like to wish everybody a wonderful evening and a beautiful Thanksgiving, whether alone or with friends or family, as you can safely be. So
wear a mask.
Thank you.
Don't be an idiot.
Yes, wear your mask.
Thanks.
Thank you so much. Good night.
Good night.
Thank you, everybody.